Okay, here we go. Boo ba doo ba da ba doo ba ba da dum. It's quiet in here because last time I did a stream, they shut down my thing because of copyright stuff. I don't really know how to get around that. Anybody here? I don't actually know. I'm going to start in a minute if nobody's here. I'll just record it and post the video. And then if people pop in, we can answer questions. Copyright music with vocals. Ah. What is this? Ads? Get out of here. Alright. I think we got music now that's not going to get us copyrighted. Oh. Cool. Alright. So, I'm going to go ahead and start talking about this trigonometry stuff. And if anybody pops in to ask questions, we can just, pause and answer them as we go. Stream quality is really bad right now. Okay. Cool. So today we're going to talk about some trigonometry stuff. I'm going to do a reintroduction or cover again how we got into the three primary trigonometric ratios again. So this will be a review for people that were in class before we took our unexpected closure, but that'll be okay. And then we're going to move on to finding missing sides and angles of a right triangle. And then, depending on how time goes and such, we'll get into maybe the looking at some of the reciprocal identities and the inverse and such like that, okay? We'll see how far we get with the time that we have and who shows up, okay? So, as a brief reintroduction to what we're talking about with this right triangle trigonometry stuff, okay? We can use right triangle trigonometry when we're trying to deal with... Wow, is the stream quality really that bad? I hope it comes out better than this. Okay. We can use trigonometry to understand the relationships between angles and sides of right triangles, okay? It's really important that we remember that we can only apply this understanding to right triangles, okay? Just right triangles is what we're talking about, okay? So let's take a little bit of review of what we know about right triangles already that we've learned in previous classes, okay? So sum of angles in any triangle is going to be 180 degrees, okay? The hypotenuse is the name that we call the side that's opposite of our right angle, okay? So let's take a look at this triangle and see if we can remember what all these things are. Okay, so this rectangle here in the corner signifies that we have a right angle here, okay? That's where our right angle is, which means that this side over here is our hypotenuse. Okay? So we have our hypotenuse is always this longest side. Okay, it's always opposite our right angle. Okay? And there's another thing that we like to use in this triangle trigonometry. We use angle theta. Okay? We'll talk about angle theta. Let me redraw that. Angle theta. That looks better. Okay? And that's called theta. It's just a symbol used to describe angles. Okay? And then another thing that we know from geometry, hopefully, is that we can use the Pythagorean theorem to find missing sides of a right triangle. Okay? We can use the Pythagorean theorem. So if you guys don't remember what that is, it says a squared equals b squared plus c squared. A squared being the hypotenuse. Okay, so if we were to label these sides here, I'll label them in green. Okay, we call this side A. Okay, the longest side is equal to the sum of the square. The square of the longest side, a squared, is equal to the sum of the squares of the two other sides, B and C. Okay, C. All right. So that's another thing we can use. Doesn't involve trigonometry at this point, but that's just another thing that we can use to understand the sides of a right triangle. So our trigonometry, so we use three basic primary trigonometric ratios to describe the relationships between two sides and a specific angle. Okay, and the process we use for that goes like this. Okay, now it's really important that we recognize that we're talking about a specific angle. Okay, so the process we use here is our first step is we want to identify our angle. We have to always identify the angle that we're talking about. Okay, so I'm going to go ahead and just mark one of these angles with theta. Let's mark this one with theta, okay? So there's our angle, okay? Step 2, label our sides, okay? Okay. So the sides of our right triangle here, we've got the longest side is always opposite of our right angle, we remember. That's always our hypotenuse. Okay. I'll also just refer to this as H, okay? And then the other two sides that we talk about in trigonometry are adjacent and opposite, okay? Opposite and adjacent. Adjacent means next to, so our adjacent side is the side of our triangle that is a member of this angle theta, okay? So this is our adjacent side here. Call it A, okay? And then opposite is the one that doesn't touch our angle, okay? Our angle's over here, the opposite side is right over here. Let's see if I can write this sideways a little bit. And that's not gonna work. We'll have to do this though. Oh. Oh wow, this is going bad. Nobody's here yet. Okay, cool. I'll just keep going. Opposite. And I'll mark that with an O. Okay? Sweet. So we identify the angle we're talking about, this angle theta. We mark with our sides, we label our sides. Hypotenuse is always the longest, adjacent's next to our angle, and opposite's across from our angle. And then step 3, we can now write out our relationships, our ratios. Okay? And we have three primary trigonometric ratios, okay? The first ratio is going to be called sine, okay? And that one we write like this, sine theta, okay? Sine of whatever our angle is, okay? We always short it to a 3-letter version, okay? And that's going to be equal to the opposite side over the hypotenuse. It's a ratio, so it's a fraction. Opposite over hypotenuse. Okay? Next ratio, cosine. We write as cos theta, cos theta. Okay? And that one's going to be adjacent over hypotenuse. And our third ratio is tangent, which we can abbreviate as tan theta. And that's going to be opposite over adjacent. Okay? So we have these three relationships that relate a trigonometric function of our angle. Okay? Sine of theta is going to equal the length of our opposite side divided by the length of our hypotenuse. Okay? Cosine is the length of our adjacent side divided by the length of our hypotenuse. Tangent is opposite divided by adjacent. Okay? And there's a really nice word or phrase that we use to help us remember this. Okay, so I'm gonna write that out. It's so ka toa. Okay, so ka toa. So ka toa. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay? So this is our little star over here. Okay? This is our special little guy to help us remember. Alright? SOHCAHTOA. So what now we're going to do is we're going to take a look at an example of how we go ahead and find the trigonometric ratios for an angle T in this example triangle here, okay? Here we have triangle GRT with side lengths 8, 15, and 17, okay? And the question is, we have to find the sine, cosine, and tangent ratios for this angle T, okay? So first step, as we remember, is we want to identify the angle. So T is right here, right? All right, T is right here. Let's do it in a different color. Let's do it in green. All right, angle T is right here. So now I want to do step 2, label the sides of our triangle. Hypotenuse is always across from our right angle. Okay. Opposite is always across from our angle T. It doesn't touch our angle T. And adjacent is going to be next to our angle T. All right. Now I'm going to help myself out by writing SOHCAHTOA up here, so I can remember easily. Okay. So sine is opposite over hypotenuse. And that's going to be 8 divided by 17. Awesome. Cosine is adjacent over hypotenuse. So A over H. And that's equal to 15 over 17. Let me fix that 15 real quick. I'll just rewrite it. 15 over 17. And then tangent of t is going to be opposite over adjacent, opposite over adjacent. Opposite is 8, and adjacent 15. Awesome. So we've got our 3 trig ratios for our triangle GRT over here, okay? We could simplify these if they were reducible, but in this case, they're not quite reducible, all right? Awesome. So here's an example practice problem that you guys can do if you want to maybe pause your video for a few minutes and work it out. Okay, I'm gonna, go ahead and pause it now if you want to work this problem out. See if you can find the sine, cosine, and tangent ratios for our triangle DEF over here, okay? And once you unpause it, I'm just gonna continue explaining it, okay? You can check your answers, all right? Great, so now I'm gonna go over and review this problem. Sine, cosine, and tangent for our angle D over here, okay? So we're talking about angle D. All right. I'm gonna go ahead and label my sides, blue I guess. Hypotenuse, H, opposite O, adjacent A, okay? We've got sine of D equals O over H, right? So it's going to be 8 divided by 10. And we can reduce that. We can divide each of those numbers by 4. Okay, so we'll get... Oh, sorry, we can divide each of those numbers by 2. I'm sorry. So we get 4 over 5. Okay? What about cosine of D? Cosine of D is adjacent over hypotenuse, which is 6 over 10, which reduces to 3 divided by 5. And then tan of D is going to be equal to opposite over adjacent, which is 8 divided by 6, which we can reduce to 4 divided by 3. Sweet. So we've got our trigonometric ratios figured out for this triangle here. If the answers you got weren't fully reduced, don't worry about it. You won't lose points on a quiz if you don't reduce your fractions, but it's generally just easier and best to do that, okay? The next thing we're going to do is we're going to learn how we find a missing side using trigonometry, okay? It's going to be the same process we were using before, except now we have a different unknown, okay? Or we have a unknown, all right? So when we do this process, what we're going to do, I don't have to zoom out, it'll be fine. Can't scroll though. So what we do here is, we're going to start by looking at, we're going to do the same steps we do before, okay? So 1, pick your angle, or identify your angle. Let me start that again. Okay, and our angle here is this 54-degree angle here, right? It's this guy. Okay, so now we've identified our angle. Step 2, label our sides. All right, so here's our angle, our hypotenuse, always across from the right angle, H. Opposite is across from our angle, and adjacent is next to our angle. Okay. Step 3 is we have to find out which trigonometry ratio we're going to use. What are the sides? Which ratio? Okay. Well, we're looking for side W, which is our opposite. Okay. And we know side H. Okay. So this, I'm going to write SOHCAHTOA up here. So the side that deals with our opposite, or the trait ratio that uses our opposite and hypotenuse, is sine, okay? So we're gonna write out our ratio now. Sine of 54 is equal to opposite over hypotenuse, okay? Which is equal to W divided by 17. It's supposed to be 54. Hope that's clear. All right. So sine 54 is equal to W over 17. And we want to solve for W. We want to solve for W. So all we're going to do is we're going to multiply by 17 on both sides. 17's cancel. Okay. And then we get W is equal to 17 sine of 54. And that we can plug into our calculator. So we're just going to do, I think we have to do 54 first, then hit sine, yep. Then multiply by 17. 17. And we get 13.75. 13.75. There we go. And it's always important for us to take a look, make sure that answer makes sense. Okay? And for that answer to make sense, we just want to look at here and say, all right, well, that should be less than our hypotenuse, but not a lot less than our hypotenuse, right? That makes sense. Answer looks to make sense. All right? So what I'm going to do now is I'm going to show you guys a problem that you can work out. Find our missing angle over here, or missing side length, W over here, okay? So go ahead and pause the video if you want to work this out. And in a few seconds, I'm going to go ahead and explain it. All right, cool. So we're going to follow the same process we used before, okay? We're going to identify our angle. Okay, our angle, this 28-degree angle is right here. So now we can label our sides. Opposite is across from it. Adjacent is next to it. Hypotenuse, always our longest side, always across from our right angle. And we can pick our ratio. Okay, what's our ratio going to be this time? Well, we're looking for adjacent side, and we know the opposite side. So the ratio that deals with opposite and adjacent is tangent. Tangent, okay? So we're going to use tangent equals opposite over adjacent. All right, so let's write out our relationship. Tangent of angle, I guess we'll call that tangent 28, sorry, is equal to opposite, which is 1.0, divided by W, our adjacent, okay? So now we've got a W on the bottom, which isn't really great. We want that W to not be on the bottom of a fraction. So what we're going to do with that is we're just going to multiply by W on both sides. Okay, and then we get W tan 28 equals 1. And now I'm just going to divide by tan 28 on both sides, because that's just a number. Those cancel. And now we get W equals 1 divided by tan 28, which is equal to, using our calculator, 1 divided by 28 tan 28, 0.53. Let's just say 0.53. Does that number make sense? 0.53. It doesn't look like it makes sense to me. I think that W would be longer. Anybody here? No? Anybody find my mistake? Tangent of 28 equals opposite over adjacent. So that'd be 1 over W. 1 divided by tan 28. Oh, there we go. I didn't hit equals. Ha! I was like, I thought I did this right. 1.88. Okay, there we go. I didn't hit the equal sign. There we go. Oops. Cool. All right. 1.88. If you guys got that number, good job. If not, I hope you understand, what went wrong. All right. And at this point, let's see. How much time are we on? 25 minutes or so. I'm going to go ahead and give you guys some applications problems. Okay, so how do we actually apply this to real world? Okay, and there's a lot of applications in the real world, especially when you're dealing with engineering problems or science. When you're looking at even chemistry, you're going to be dealing with trigonometry and stuff at some point. You'd be surprised. So this trigonometry shows up everywhere because triangles show up kind of everywhere in the world. All right. So here's an example of a problem where we could use trigonometry to help us understand this problem. It says a nursery plants a new tree and attaches a guy wire to help support the tree while its roots take hold. That's pretty common. I think I see those on trees around the city a lot. An 8-foot wire is attached to the tree and to a stake in the ground. All right. From the stake in the ground, the angle of elevation of the connection with the tree is 42 degrees. Find to the nearest tenth of a foot the height of the connection point on the tree. Okay, cool. That makes sense. I guess if you have like an 8-foot cord and you know that you want it to be held at a certain angle, then you just need to pick whatever height you do and then pull that thing out and you'll be all good to go. Cool. So we'll find that length x. All right. What do you remember about our steps? Step 1, we pick our angle. It's this 42-degree angle over here. Step 2, we want to label our sides. Hypotenuse, adjacent, opposite. All right. Step 3, we want to pick our ratio. Okay. I'll write SOHCAHTOA up here to help me again. SOHCAHTOA. So it looks like we're looking for the opposite side, and we know the hypotenuse. It's O and H, so that would be sine. All right, so I'm going to use sine. 42 is equal to O, which is x, so x divided by h, which is 8. Boom. Now we need to find x, so we're going to just multiply by 8 on both sides. 8. And we get x is equal to 8 times sine of 42. Let's find that number. 8 times sine of 42 equals 5.35 feet. All right, see if that makes sense. 8 foot, it's definitely less than 8 feet. Yeah, okay, cool. That number seems to make some sense. Great. Another applications problem for you guys to try. If you guys are watching this video, go ahead and pause it. And nobody's in chat, right? Yeah, looks like I'm alone over here. Cool. So, sorry. It's really nice out today. I got those allergies going. So, here we go. We're going to find the shadow cast by a 10-foot lamppost when the angle of elevation of the sun is 58 degrees. Find the length of the nearest tenth of a foot. Cool. So we have the sun up here. It's casting a shadow. And if we know what the angle with the sun is, we can actually find out how long that shadow is. So how long is that shadow? Step 1. Let's label our angle. It's over here. It's 58-degree angle. All right. Step 2. Hypotenuse is right here. Opposite side. And then our adjacent side. Great. Step 3, let's pick a ratio. All right, SOHCAHTOA. SOHCAHTOA And we've got our unknown is our adjacent side, and this side that we know is our opposite side. So O and A, it looks like we're going to use tangent. Use tangent this time. All right, tangent. So let's write out our tangent ratio here. Tangent of 58 is equal to opposite over adjacent. So that's going to be opposite is 10 feet divided by adjacent, which is x. That's the side that we're looking for. All right, cool. And if we remember from before, the way that we can solve for the x here is we're going to multiply out x on both sides. And we get x tan 58 equals 10. And then we're going to go ahead and divide by tan 58 this time. Divided by tan 58. And we get x is equal to 10 divided by tan 58. And now that our x is alone over there, we can plug this into the calculator. Just got a bunch of numbers. 10 divided by tangent of 58 equals 6.25. Does that make sense? Yeah, I guess so. Makes sense to me. Should be less, because this is a angle greater than 45 degrees. Cool, 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 cool. All right. So there we go. That's how we use the three primary trigonometric ratios to find missing side lengths. Okay. And I guess, let's see. Most useful thing to do now. Nobody's here yet still, right? Okay. That's okay. So what we're going to do now is we're going to take a look at reciprocal trig identities, okay? So if we remember, we have our primary trigonometric identities, sine, cosine, and tangent. So katoa, sine is opposite over hypotenuse, okay? Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent, okay? So we have reciprocal trigonometric identities, which are just when we take those first three trigonometric identities and we flip them upside down. We just flip them upside down, okay? So cosecant, we write out as, let's write this in black, cosecant theta, okay? Oh. Sine opposite, this should be theta right here. Theta, okay? And cosecant theta is going to be, when we flip opposite over, instead of opposite over hypotenuse for sine, cosecant is going to be hypotenuse over opposite. Okay, we just flip the fraction. Secant, we write out as secant SEC theta. Okay, and this is the reciprocal of cosine. Okay, secant theta is equal to hypotenuse divided by adjacent, h over a. Okay, and then cotangent is going to be the reciprocal of tangent. We write cotangent as COT theta, and that's going to be equal to a divided by o. Okay. Now, we're not going to have a lot of, we can also use all of these relationships for the same purposes that we would use the three primary trigonometric relationships, okay? We're just going to have new opportunities to use these depending on what information we're given in the original problem, okay? So let's just get a little practice understanding how we write out these identities in terms of adjacent, opposite, adjacent, and hypotenuse, okay? So we see that, I'll do cosecant in blue, no, purple. We have cosecant theta is 1 over sine theta, okay? So sine theta is going to be, if we remember, opposite over hypotenuse. So ka toa. If sine is opposite over hypotenuse, cosecant, if we say 1 over sine theta. Whenever you take the inverse of a fraction, it's the same as taking the reciprocal. You flip it upside down, okay? So the reciprocal of sine theta is going to be cosecant theta, and that's hypotenuse divided by opposite. Okay. Similarly, we have secant theta equals 1 over cosine theta. Okay. Cosine theta, if we remember, is adjacent over hypotenuse, which means that if we take the reciprocal of cosine theta, we're going to get h over a, and that's going to be equal to secant theta. Okay? And then for our last one, we've got cotangent theta. That's equal to 1 divided by tan theta. Okay, remember that tan theta is opposite over adjacent. So therefore, cotangent theta is adjacent over opposite. Okay, here we go. The way that I remember that cosecant is the inverse of sine, secant is the inverse of cosine, and cotangent is the inverse of tangent. Oh, I just noticed that cotangent is not spelled right. Hold on a second. So tangent. Right. There we go. Alright, so because I remember we have sine and cosine, so cosine is a cosine. So pretty much every pair has a co in it. So sine and cosecant, cosine and secant, and then cotangent and tangent. All right, so there's a co in each one of those pairs. Does that make sense? Cosecant, sine, secant, cosine, cotangent, tangent. Tangents with tangent. Okay, cool. There's the trick I use. All right, sweet. So let's practice finding the trig ratios for our angle t again, but the 4 through 4, 5, and 6, okay? Cosecant, secant, and cotangent. Whoop, 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 whoop. I don't write out a different like phrase to help me remember these. I just kind of remember cosecant's the opposite of sine, secant's the opposite of cosine, cotangent's the opposite of tangent. Okay, so cosecant t, well, let's see. First step, angle. Second step, we still want to identify hypotenuse, opposite, adjacent. Okay, so cosecant of t, remember, is going to be the opposite of sine, hypotenuse over adjacent. Okay, and hypotenuse is 17. I said hypotenuse over adjacent, I meant opposite, I'm sorry. And so we have 17 divided by the opposite, which is 8. Okay, secant is the opposite of cosine, or the reciprocal of cosine, sorry. Okay, so we're going to have h over a. Okay, and h over a is 17 over 15. And for cotangent, opposite of tangent, we have a over h. Okay, and that's going to be equal to 15. Oop. I'm so sorry, guys. Brain fart. A over O. Yeah. Adjacent over opposite, 8 divided by 15. Okay. None of these fractions can be reduced. Okay. 17 is prime. These guys don't share a factor. All right. So these would be our three other ratios for this triangle over here, GRT. So in that case, I'm going to give you guys some time to practice finding this. If you want, go ahead and pause the video now. Nobody's in here, right? Cool. So go ahead and pause the video if you'd like. And I'm going to walk through this triangle in just a second. Okay. I'll leave this timer over here, but that's fine. So we're looking for angle D here. So we're looking for this angle. Let's mark our sides: hypotenuse, opposite, adjacent. All right, and we want to find cosecant of D. We want to find secant of D, and we want to find cotangent of D. All right, so cosecant is h over O, which is going to be 10 divided by 8. 10 divided by 8, which you can reduce to 5 over 4. Secant, h over A. Hypotenuse divided by adjacent, that's going to be 10 divided by 6. And that's going to be equal to 5 thirds. And then cotangent, A over O, adjacent over opposite. It's going to be 6 divided by 8. Okay. And 6 divided by 8 reduces to 3 over 4. So there we go. Can't draw straight lines for the death of me. So there we go, guys. That's how we find these reciprocal relationships. Okay, we've got our 3 primary relationships: sine, cosine, tangent. 3 reciprocal identities: cosecant, secant, cotangent. Okay. Let's see. Nobody's here. If you guys want to do, I'll go ahead and leave this up for practice. If you guys want to do this, if you're watching the video, I'll write up these answers real quick so that you guys can see these. Go ahead and pause it right now if you want to work them out, and I'm about to work them out. So to find the missing side x here, we're going to identify our angle as this one. Okay. Our sides are opposite, adjacent, and hypotenuse. I'm going to write SOHCAHTOA to help me out. Okay, so the ratio we want to use is going to have A and H in it. So A and H is cosine. So we're going to use cosine. So cosine 68 is equal to adjacent over hypotenuse. So x divided by 17, which means that I just need to multiply by 17 on both sides. 17. And then we get x equals 17 cosine 68, which is equal to 17 times cosine of 68. Mm-hmm. 17 times cosine of 68. I did something wrong here. Cosine, adjacent over hypotenuse. X over 17. X over 17. So x equals 17 times cosine 68. There we go. I had it in radian mode. We'll get to that later in this unit. Radians and degrees are different, so if you're in radian mode, you'll get something wrong. All right, there we go. A number is 6.37. That makes sense. 6.37 for our length of x. Shorter than the hypotenuse, but still, you know, in the right order of magnitude. It wasn't 0.3. I knew that 0.35 was wrong before. We had it in the wrong mode. Okay. So 6.37. And then over here we want to find the 6 trig ratios for angle theta of the below triangle. Right, so angle theta is right here. So hypotenuse, opposite, and adjacent. We've got sine of theta is going to be opposite over hypotenuse, so 12 over 21, which simplifies to, we can divide each by 3, so we got 4 over 7. Cosine of theta is adjacent over hypotenuse, so that's 8 over 21. Can't simplify that. Tangent of theta is going to be opposite over adjacent, right? So 12 over 8. And we can reduce that, divide each by 4, okay, and we get 3/2. Sweet. Okay, let's move all this junk over for a sec. Cool. Continuing on with our reciprocal identities. The reciprocal of sine is cosecant, CSC theta, sine cosecant. And that's going to be 21 over 12. 7 over 4. Just take that fraction and flip it upside down, actually. Right? Cosine, the opposite of cosine is secant. Secant theta is going to be, when we flip this one upside down, 21 divided by 8. And then cotangent is when we flip the tangent upside down, 2 over 3. Boom. So I hope you guys got all of those right, or if you didn't, you understand kind of what went wrong there. And the last thing we're going to cover today is how we find missing angles in a triangle using our trigonometric ratios, okay? So at this point we know what the 6 ratios are, okay? And we know how to find a missing side, all right? So there's one other thing we can do with these trigonometry ratios, or there's another thing we can do, which is find the inverse of them, okay? There's a difference between inverse and reciprocal, okay? Reciprocal is when we take the ratio and we flip it upside down. The inverse sign, okay, tells us the inverse sine, inverse cosine, and inverse tangent can be used to find missing angles in a triangle, okay? So when we give them a ratio, they produce an angle in response, okay? So let's take a look at how this works out in practice, all right? We're going to start off by using the same steps we had used before, okay? We're looking at angle x here. I'm going to put a little star next to it. I'm going to say, all right, we've got opposite, hypotenuse, and adjacent here, okay? And I have the opposite. I know the opposite and adjacent sides, all right? I know the opposite and adjacent sides. So I know that tan of x is equal to 4 divided by 8. Okay. So remember, x is an angle in this situation. All right. The inverse of tangent, so tan to the -1 is how we write inverse tangent. So I'll write this here. Inverse tangent is written as tan to the -1 of our whatever our angle is. Okay. I'll do that. Or angle theta, okay? So the inverse of tangent is tangent to the -1 theta, okay? And what? Tan to the -1. And the way we write that out, it's not with the theta, but with the angle, okay? So we write it as tan -1. And so tan -1 orange. We write tan to the -1 of our tan is adjacent over opposite. Opposite over adjacent. Okay, so we write tan to the -1 of opposite over adjacent. So of our ratio of our sides is equal to our angle x. Okay. So now, instead of saying a tan of our angle is equal to the ratio, the inverse tangent of our ratio is equal to our angle. All right, and this inverse tangent is another function that we'll find on calculators, okay? And in this case, we have tangent to the -1 of 4 divided by 8 equals x. And that we can put into our calculator. 4 divided by 8, that's going to be 0.5. And then where's inverse tan? I actually know how to do it on this calculator. It doesn't have inverse tan. Second? Oh, there we go. So it's second. Okay, so let's clear this out. 0.5 second tan. All right, tan negative 0.5 is 0.46. Okay, let's put it in the degree mode. All right, degree. -1. Oh, it's in radian. Right. Okay. I don't know what's going on right now. Sorry, guys. Trigonometry. Second 1. There we go. I had to put it in degree mode first. Okay. Sorry about that. All right, so tan negative 1 of 0.5 is 26.6. All right, if you got something that doesn't make sense, make sure that you're in degree mode and not radian mode, okay? We're going to learn about radians later, but radian is another unit that we use to measure degrees, okay? So we put that in the calculator, we get x equals, what was it, 26.6. All right. That's what we get. All right, so that's how we find missing angles. All right, so pretty much all of these inverse, sine, cosine, tangents, they all tell us, you know, what the what the angle that would be required to give us a sine value of whatever this ratio is. Okay, it asks us what is the angle required to give me that sine value. All right, so we can practice by just kind of typing these in to a calculator to get some practice. If you guys want to give a shot. I'll just work these out with everybody together here. Okay. Over here, we're going to type in our 0.82, and then we're going to do second sine negative 1. So we have sine negative 1 of 0.82. That's equal to 55. Well, hello. Fit. Did my smart notebook freeze? Yo! That's never happened before. Sorry, guys. Wait, hold on a sec. I'm gonna fix this. Do da 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 do. Da 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 da. Are we good now? What is going on? We're just gonna reopen that one. Sorry, guys. No. All right, here we go. We're back in action over here. I think we're good. I think we're good to go. All right, cool. Sorry about that. All right, so we had 55.1. 55.1 degrees. All right, this one we can plug into our calculator just the same way. Make sure we're in degree mode. We have 0.98 second cosine 11.5 degrees. So we're good over here. All right, this keeps breaking. Oh. broke it again. Wow. I think I figured out why I broke it. Alright, so this one we had 11.5. And then on the other one, we had tan and negative 1 of 3. That's a pretty weird one. Alright, so we're going to do 3 second tan, and we get 71.6 degrees if we round that one up, okay? So 71.6 degrees. Alright? So these are things we just type into the calculator, assuming that we found the ratios, okay? We just type these in, find these angles. So we're going to walk through how we would solve these two triangles here, finding a measure of angle x to the nearest degree, okay? I'll do the first one up here, and then I'll pause and give you guys a second to do the second one. See if you can figure it out, okay? Just cover it up for now. So we're looking for angle x, right? Angle x. That's this guy right here. We're taking our same first steps. We've got hypotenuse, opposite, and adjacent. Okay? We label our sides. We need to pick a ratio. I'll remind myself up here with SOHCAHTOA. There we go. So, what do we got here? We got the opposite and adjacent sides that we know. So opposite and adjacent uses tangent. We've got tangent of angle x is equal to, opposite is 6, adjacent is 9, so 6 divided by 9, which means that now we can write the inverse, okay? Tangent to the negative 1 of 6 over 9 is going to be equal to x. Okay, so the inverse tangent, we plug in our ratio and we get our angle. Okay, and that one's going to give us, what do we get? Calculator. Let's clear this out. We have 6 divided by 9. Trigonometry second tangent. 33.7 degrees. Does that make sense? Makes sense to me. Looks reasonable. 33.7 degrees. Awesome. It's the first one. All right. We found that. Boom, bam. We did that. We did that. All right. So if you guys want to go ahead and see if you can find the measure of angle x this time, you know, we're looking at this angle. Go ahead and pause the video and resume it when you're done finding it. I'm going to go ahead and explain it. So the first step, identify our angle. Second step, label our sides. So hypotenuse, opposite, adjacent. Pick our ratio. Our ratio, we know adjacent and hypotenuse. Adjacent and hypotenuse use cosine. So I'm going to say cosine of x is equal to adjacent over hypotenuse 16 over 20, which I'll simplify to dividing by 4, we got 4 over 5. All right, cosine of x is 4 over 5, which means that the inverse cosine, cosine negative 1 of 4 over 5 is going to be equal to our x, our angle. All right, plug that into the calculator, we get 4 divided by 5. Second cosine, we get 36.9 degrees. Awesome. There we go, everybody. So I hope that was helpful. I hope that was helpful in how we understand how to find missing angles. Okay, I'm just going to go ahead and write those angles in over here. 33.7 degrees. This one's 36.9. You don't have to write it in there, but I like to do that just because it's there now. Cool. Yeah, we're gonna So we're gonna go ahead and take a break there. You guys should be able to do any of the Delta Math practice now. That is that is already up on Delta Math, as well as that Delta Math assignment that was given before break, okay, for our emergency vacation. So go ahead and if you have any questions, please feel free to ask me either here on Google Classroom or send me an email, and I'd love to help you guys out with any of this. Thank you, everybody.